Hello everyone and welcome back. Today we are going to learn why is multi-programming important. Imagine a supermarket with only one cashier. Customers must wait in a long line, wasting time. Now imagine the store adds multiple cashiers, allowing many customers to check out at the same time. This will improve the efficiency and reduce waiting time. This is exactly what multiprogramming does in a computer system. Instead of running one process at a time, multiple programs are executed simultaneously, making the system much faster and more efficient. In today's video, we will explore two important multiprogramming memory management techniques: fixed partition and variable partition, to understand how operating systems manage multiple programs efficiently. So let us type in. Firstly, what is multiprogramming? So multiprogramming is a memory management technique that allows multiple programs to be loaded into memory at the same time to increase the CPU utilization. Instead of waiting for one program to finish, the CPU switches between multiple programs at the same time. This reduces idle time and ensures the system is always doing useful work. However, multiprogramming requires efficient memory partitioning to manage multiple processes. Think of a real world example think of a chef preparing multiple dishes at the same time. While one dish is cooking, the chef can start preparing another, optimizing time and resource at the same time. Or think of your mother cooking dishes. On one side, uh, he is preparing lentils, and another side he is preparing the rice. Then, what is fixed partition memory multiprogramming? So, firstly, we should ask what is fixed partitioning. So, the memory is divided into fixed size partitions before execution. It means that their size is fixed. Each partition can hold one process at a time and not more. The partition sizes are decided in advance and do not change dynamically. If a process is smaller than a partition, the remaining space is wasted, which is also called internal fragmentation. Imagine a parking lot. Okay, in a parking lot with fixed size parking spots, a small car still takes up a full large spot, wasting space. For example, if the parking space is for 7 feet car, but the car that is going to be there is only 3 feet, but it will still take the 7 feet space because it is fixed. So in the fixed partition multi-programming, there are some steps. Firstly, the operating system divides the memory into fixed partitions. Then the processes are loaded into available partitions. And then when a process finish, a new process can occupy that partition. But there was some problems like we discussed just right. Internal fragmentation, it means that the memory that is not used within the partition will be wasted. Then we have limited process size. A process cannot be larger than the partition size. If the process is larger than the partition size, will be not be able to load on that set or on that slot. Then inefficient use of memory. In the partitions, there are some partitions which may remain empty if no process fits, which is greater than the slot. Uh, think of a theater with fixed size seats. If a person is smaller than the seat, the extra space is wasted and no one else can use it, right? Yeah. So, moving further, let's see. We have just saw what is fixed partition multiprogramming. But to solve the disadvantage of this, we got introduced to variable partition multiprogramming. In variable partitioning, memory is divided dynamically based on the size of incoming the process. No predefined partition sizes. Each process gets exactly the memory it needs, whether it is large or small. So, in this way, there is more efficient memory utilization than fixed partitioning. For example, imagine a flexible parking lot where there is no particular slot and each car gets a parking space based on its actual size, not the fixed slot, so that it ensures that no space is wasted and more cars can be adjusted. But there are some problems with this technique also, like external fragmentation. The memory in this becomes fragmented as different size processes come and go. And then we have compaction needed. Sometimes the memory must be arranged to create larger continuous blocks because they are necessary at that time. Now, let me give you an example. Uh, a flexible seating arrangement at a wedding. Okay, the guests are seated based on the available space, but after some guests leave, empty spots appear, which requires management and then refilling of those seats. But why are we studying this today and why it is important? So most of the modern operating system no longer use simple fixed or variable partitioning. Instead, they have evolved into advanced memory management technique such as paging. Paging divides the memory into fixed size pages to avoid fragmentation. Then segmentation. So what segmentation does is it divides the memory based on logical program sections. Then we have the virtual memory also. Virtual memory, in the virtual memory we uses disk storage. Okay, we use disk storage as an extension of RAM for better efficiency. An example of this is the operating systems like a Windows, Linux, or even the Mac OS. They use paging and segmentation instead of fixed or variable push partitions to efficiently manage memory. We will be learning about paging, segmentation, and virtual memory in detail in the coming lectures. So hit that subscribe button if you want to learn more. Now, coming on to what we have learned in this lecture, multiprogramming allows multiple processes to run efficiently first by managing memory allocation. We learned about two techniques in this. The first one is fixed partitioning, where memory is divided into fixed blocks, but it can lead to internal fragmentation also. Then we have variable partitioning, where memory is allocated dynamically but can suffer from external fragmentation. So, the modern operating system memory management has evolved beyond these simple methods. But if we want to learn the advanced techniques, we have to first know the fundamentals of this. It will help us how computers have improved over time so we can have a better understanding. So, before jumping onto the advanced topic, it is better to improve our fundamentals. Okay. So, if you found this video helpful, don't forget to like, share, and subscribe for me more easy to understand tech explanations. See you in the next one. Thank you.